We are live, sir.
Yeah, good evening, ladies and gentlemen. Welcome to this first session on doubt clearing session for the engineering side from HIMT. This has been powered by HIMT, and we have our faculty, senior faculty, Mr. V.R. Venkateshan, who has been our post in charge for class 1, class 2 for last about 15-20 years. He's been the posting of our class 1, and he's presently the academic director of all the HIMT group. We also have Mr. Janaka, S. Janaka, who is Director Engineering. He's also been with HIMT for more than about 16 years, and he's been into various engineering courses and electrical and ETOs, etc. So again, basically from education, he's an electrical engineer who converted to the chief engineer on board and is currently the director engineering. We also have Mr. Ganapati Rao, who is here with us. He's been with various shipping companies. He was the vice president of Good Earth and many other shipping companies prior joining HIMT. He's right now the director of placements. He takes care of all those activities and also a faculty for our engineering courses. So we have three dignitaries in the panelists who are certainly here, who will be sharing this particular session. Collectively, they'll be sharing across. The whole idea of having this session was based on the feedbacks what we received from the various industries, from the shipping companies, from the students, from various other people who are associated with HIMT, and they were saying that they wanted to have something novel where they could ask their doubts. Okay, we do conduct courses, but then what about the students from other institutes? They also say that if we can kindly ask the faculty of HIMT a few questions. So knowledge is wealth and we like to share it. So we just thought, because HIMT students, we have this feature of mock orals, etc. regularly. But then what about the students and what about the seafarers who are sailing on board vessels? They also might like to have some doubts when they're on board. So we thought that we'll just initiate this particular part of it. And today being the first session, we'll just start with the session with the prayers. The Almighty take his blessings, and then we'll start across. So can I just have the moderator to play up the video, please? Moderator, can you play the video, please?
Please make me as co-host, please.
Yeah.
Asato ma sadgamaya tamaso ma jyotirgamaya mrityorma amritam gamaya sarvesham swastir bhavatu सर्वेषां शान्तिर्भवतु सर्वेषां पूर्णं भवतु सर्वेषां मङ्गलं भवतु लोकाः समस्ताः सुखिनो भवन्तु ॐ शान्ति शान्ति शान्तिः
Yeah, thank you. So let's just start off now. It's 5:05 now, and now every minute is going to be important. The whole concept is to clarify your doubts. You go to MMD exams. Generally, you have the students being examined by the examiners, but then for a change, we have seen that people wanted to see how the faculty take it across. So it's certainly it requires a lot of guts to have this open on a YouTube, because we are confident of faculty, and that's how they are here. And you can shoot out any questions from any part of the world, and we'll try to answer each of the questions possible. My only request would be to kindly keep your questions short, because we'll not be able to explain a detailed answer right away, but then certainly we'll try to answer as best as possible, and we'll try to address each and every question. So over to you, lead examiner now, Mr. V.R. Venkatesh. Over to you. Thank you.
Thank you, sir. Good evening, participants and my esteemed colleagues. So enough has been taught already about the importance of this program. So let us go straight away with answering the questions. Already quite a few questions are there in the posted already. So we will select and we'll answer them one by one. Because many questions are there, we will not be able to give very detailed answers to some of these questions. But we'll focus on what is being, what is the gist of the important principle that is there. Okay, so I will start with the first question. There is a question from Mariner Siam. It just says accumulation of pressure in boiler. So I would assume the question is related to accumulation of pressure test, but in a boiler. So the important thing to understand is that boiler is a pressure vessel. It is a fired pressure vessel where the pressure is built up by you burn fuel, you turn water into steam, and pressure will build up. And the idea is that you burn with the heat, you produce steam, and the steam is to be consumed. And to protect the boiler from excess pressure, a lot of safeties are already built in. You have high pressure alarm, you have high pressure trip, but in addition, you have a safety valve. Now, all of you will be knowing that the safety valve is set at a particular pressure. It is related to the maximum working pressure of the boiler. So the highest setting allowed for the safety valve is 3% more than the maximum working pressure. So we normally say 1.03 times the maximum working pressure the safety valve should lift. The important point to understand is if the safety valve lifts, that alone doesn't ensure safety. Because if steam is getting generated in the boiler and the safety valve is lifted, the safety valve should have enough capacity to release the steam. It's called relieving capacity of the safety valve. It is not just a warning device. Its job is to allow the steam to escape and protect the boiler from excess. So there is a test required, which is called accumulation of pressure test. And the simple purpose of the accumulation of pressure test is you are verifying whether the safety valve is of sufficient capacity, its size or relieving capacity of the safety valve is sufficient. That is the verification. So for this verification, you will take the worst scenario, which is that there is no steam being consumed anywhere. The main steam stop valve is closed and the boiler is firing at its maximum firing rate. And there is no input even of water coming. There's no feed water coming inside. So this is the worst possible scenario. Under this condition, maximum steam generation will be there. And the safety valve will lift. When you do this accumulation of pressure test, safety valve will lift and then the pressure will rise. Rather, the steam will start escaping. So if the valve is big enough, it should be able to control the pressure of the steam in the boiler. And the idea is that the maximum pressure allowed should not exceed 10% more than the maximum working pressure. Depending on the class, some class say 10%, some other class have limited to 7%. So during the accumulation of pressure test, the pressure should not exceed this. If it is exceeding it, it means valve is not big enough. So it is a test which is done at the in the design stage or in the first certification stage. You don't need to do it every year. It is not like setting the safety valve. Setting the safety valve is different, but you don't have to keep doing the accumulation of pressure test every time. Okay, so the main principle is it is for verifying the relieving capacity of the safety valve. Okay, so and it will be for both the valves lifting. Accumulation of pressure test with the two valves lifting simultaneously. Okay, so I hope that answers your question. Now, Mr. Janaka, there was a question related to electricity. Can you answer that question, please?
Yeah, regarding that low voltage and overcurrent trip.
Yes, sir. Yes, sir. Please.
Good evening to you all. And there are two things regarding this under voltage criteria. I'm starting an alternator, unable to build up the voltage unless it reaches the minimum setting, the breaker will not close. This we call it as under voltage release. There is actually a main purpose of this under voltage trip. It is actually called under voltage release. But on the usage, we have come to across saying that it is under voltage trip. So when the voltage comes down below set level, the breaker opens. So when you are trying out or when you are showing to the surveyor, we do this way. We bring down the voltage and show that the breaker trips off. But real meaning is opposite. Suppose generator is unable to build up the voltage, it should not be able to close the breaker. Regarding overcurrent trip, don't get confused. Overcurrent and overload are one and same. Overload means the current drawn is more. The setting can be 110% or 115% depending upon the design and depending upon acceptance. Some places it can even go to 125%. So this overload trip means when the current exceeds that limit, we have got the preferential trips. They'll trip in the sequence. Ultimately, when it's unable to still meet that overload, the complete breaker will close. So overload trip, when you want to try out, normally it is tried only by racking out the breaker. Take out the breaker completely on a trolley, inject the current to the trip coil and then test it. No adjustment in the setting, etc. Never overload the alternator. Practically, please do not overload the alternator. The cables, etc. will be overloaded. Normally done is rack out the breaker. After everything is off, power supply for the particular alternator, rack out the breaker from the cubicle, inject the current to the trip circuit. Does it answer your question, please?
Yeah, that should be fine. Now there is a question from Bhupendra Singh on the role of classification society and RO, recognized organization, and I'll request VGR sir to take this question.
Yeah, good evening, gentlemen. The recognized organization and classification is one and the same. Actually, it is a classification society which has been used by the respective flag administrations to use them as recognized organizations. Mostly, you can take any flag administration. It could be Liberia, it could be Panama, or it could be Indian flag. These classification society will apply for the RO status and they'll be given this status. So they will come and do the surveys on their behalf. It could be ISPS, it could be ISM, or it could be the trading certificates. So that is the precise role of RO, and classification societies opt for it, apply for it, and that is granted by the respective flag administration. Thank you. Hope I have answered your question.
Okay, thank you, sir.
Yes, sir.
There is a question from Mr. Bhupendra Singh. In main bearing, how blended edge design improves lubrication, and in crosshead bearing, wide pad design. So it's a bit of a long question related to bearing design. Now, what happens with in any journal bearing? In any journal bearing means we are talking of sleeve type bearings with the shaft and bearings sleeve around it. And these bearings are called as sliding contact bearings, unlike your ball roller type. And in these bearings, the lubrication we are trying to achieve is called as hydrodynamic lubrication. Now, many of you will be understanding what do you mean by hydrodynamic lubrication is that as the shaft rotates, the lube oil that we supply to the bearing should be made to develop enough pressure to support the shaft. The concept is that any rotating shaft, there will be some load, and the load will be pressing the shaft onto the shell. Now, the lube oil that is supplied only at some 3 bar or 4 bar pressure. And if you can imagine a diesel engine running, the pressure which is built up on top of the piston, the maximum peak pressure which goes is many hundreds bar, 150 bar it can. With 150 bar pressure, if the piston is getting pressed down and all the force is coming onto your crankshaft, then how can you stop the shaft from touching the shell? You need to have an oil film under the shaft which is capable of supporting it. And under the shaft, the oil pressure will become very high. And to create that condition where the oil film can support, in hydrodynamic lubrication, the rotating shaft generates it actually develops a wedge. It's called an oil wedge. It drives the oil like this under the shaft. So there is a principle which is very important in understanding journal bearing design. It is based on a curve called a Strybeck curve, a Strybeck curve. There you look at coefficient of friction on the x-axis and on the y-axis, and you look at a number called bearing modulus. Bearing modulus is called Zn divided by P. Z is viscosity, N is called sliding speed, and the denominator is P. And the larger this value, the bearing modulus, the larger this number is, the lubrication is better. That is the principle. So P is bearing load divided by area, and P comes in the denominator. So if I reduce the value of P, then the bearing modulus number becomes larger, and you'll have better hydrodynamic lubrication. So the basic concept is in journal bearings, the bearing load per area should be brought down if you want good lubrication. And how do you bring down the bearing load per area is that you are trying to develop more and more power from the engine. So you cannot reduce the pressure as such. Pressure, you are trying to achieve high MEP values, high peak pressures. So the bearing has to become bigger and bigger. And all of you will know the main change which happened with the bearings was that it used to be a fork type crosshead bearing. And for many years now that crosshead bearing has changed. Instead of a crosshead fork type, it has become the entire bottom half of the crosshead bearing is one shell. So that large increase in area resulted in reduction of this value called P, which means the bearing modulus becomes better. and if the bearing modulus is better, you will get hydrodynamic lubrication much better. So in all journal bearing designs, load per area is an important factor. It has to be kept as low as you can manage. Because putting a large bearing which is larger than required is also not necessary. But according to the size of the, according to the load coming on the bearing, you'll have to increase the size. This is the major change which has happened in these bearings. And it is applicable not only to crosshead bearing, it is also there in bottom end bearings, even in gudgeon pin bearings. Everywhere you will see there's an attempt to make the bearing size as large as you can in many applications. Okay, so that should answer the question. There is one more question called turn down ratio in a boiler. In boiler combustion system, there is this ability of the burner to operate at different capacity. Now that means you may not generate steam at the same rate all the time, depending on the consumption load that is being put into use. You will be developing steam which is of lesser quantity, and you will be developing more quantity. For that, the burner should have the ability to operate at different firing rates. So the ratio between the maximum firing rate, the maximum combustion rate of the burner, the minimum combustion rate where you can get steady flame, this ratio is called turn down ratio. Turning down, it means from maximum to minimum, how much you can do. So that is the principle. It is critical in boilers compared to diesel engines. That a diesel engine, your combustion is with atomized fuel, at high pressure atomized fuel. So you can start your generator and run it with no load at all, and the generator can go up to 2000 kilowatt. A large generator can run. But boilers are not like that. Boilers combustion is a low pressure combustion, and to maintain the flame of very small size, small flame, but to gain good combustion, and then the same flame becoming very large, producing a lot of heat, is not so easy. So depending on the type of burner, different burners have various values. Turn down ratio. Turn down ratio is larger. It means there is greater flexibility in the way you can operate your boiler. Okay, so that is the meaning. It's a ratio between maximum firing rate of the burner and the minimum firing. There is a question, sir, Mr. Janaka, sir. There is a question.
Tell me, sir.
Practical procedure of taking insulation resistance for different electrical equipment. In brief.
Insulation resistance is mainly meant for ensuring that the conductors, the varnish coating or whatever given in the winding, that is not gone in touching the body or touching the other face. In any motor or like AC motor, where you have got a distributed winding, each phase is going on alternating in the different slots. It's a winding is done in the slots. So I don't want that individual phase conductors to touch each other to create a short circuit. So we take a face-to-face measurement. So if it is a motor or the alternator, whatever it is, you disconnect the three phases separately. Check up from R phase and Y phase, check up IR value by applying the required voltage, either 500 volt DC or 1000 volt DC for a 440 volt alternator or 440 volt motor. Second thing is same insulation, it is wound on a stamping or laminations. Even laminations are insulated by varnish and the conductors are insulated by the varnish. I don't want this insulation to break. So I touch between the conductor and the body. There should be no continuity or no conduction between the wire and the body. So we say face to earth or face to body. Another one is face to face. This is to be done So if you say a real procedure, I'm taking the cable from the MSB to a particular motor. Let us say seawater pump motor. The cable is running from MSB directly. If you want to measure the IR value for cable separately for the motor separately. Don't take a combined value from the MSB. It may show more value, but individually when you check up, one of the things may show less or more. We can't say that. So we disconnect the cable from the MSB, disconnect the cable from the motor, individually check up face to face and face to ground. For a low voltage system, either we use 500 volt DC measure or 1000 volt DC measure. High voltage system, we go for, depending upon the rating of the alternator, we go for different voltages. We got 2500 volt, 5000 volt and 10,000 volt DC measure. This is called insulation resistance. Am I clear, please? Or you want more explanation on this?
No, that should be sufficient, sir.
Okay.
Sir, there is one more question.
Tell me.
It is asking what will be the effect if during synchronization the circuit breaker is closed at 6 o'clock.
See, synchronization means the voltage and the current waveform, they synchronize with each other. That is the incoming alternator and the bus bar. They have to synchronize. That's called synchronization. You say phase sequence equal, but here the phase sequence means the waveform of the voltage and the current waveform should synchronize. That normally gets done around 12 o'clock. If it is 6 o'clock, it goes 180 degrees out of phase. If you are confident, you can try, but it's very risky method, so we don't adopt that. We go for the exact synchronization, which is taking place 12 o'clock. Again, I have to give a time factor for the breaker to close. So we take it at 11 o'clock. So we got enough time gap for the breaker to close. Even if we are doing it manually or auto, it will take about a few milliseconds or a few seconds for the breaker to close. So we take up at 11 o'clock position. 6 o'clock is a little risky and dangerous. It goes out of phase by 180 degrees.
I can add one or 2 points, if I may. Now, the idea is because in an AC supply, the voltage is not constant; it is varying, right? It's always varying like this. So when the bus bar already has one AC waveform going like this, and the incoming waveform also is going to be varying. It means the what we call as the instantaneous value of the voltages may not be same. Even if the voltmeter is showing correctly, the instantaneous value may not be same. So if you are closing at 12 o'clock, what as sir said, they are synchronized. When we say they are synchronized, it means both voltage forms of R will be in step. So they go 0 at the same time, maximum at the same time, and they are again becoming 0 at the same time. Or another way of saying is the instantaneous value will be same. If the pointer is showing at 6 o'clock, pointer is showing, the synchroscope pointer is showing at 6 o'clock, it means the two waveforms are, voltage waveforms are 180 degrees apart, like that. So if you are connecting 180 degrees apart, it is similar to connecting two batteries. In one way, you can say like this: if you have two batteries, which are both batteries are plus and minus, and so if my index finger, this part is plus and this is minus, then how do you connect them in parallel? You have to put it together like this. This is the way, plus to plus and minus to minus. If you connect like this, that is voltage is apart, 180. It is similar to connecting 180 degrees apart. So at if you try to connect it, I mean, modern synchroscope will not allow you to do first. But if you try to connect at 180 degrees apart, there will be quite severe damage, because it is like the two alternators are getting connected practically in series, not in parallel, and then it is a short circuit. It is like connecting two batteries back to back this way, instead of this way, this way. So obviously you should not do it. I hope none of you will try to do it and to see what happens. If you want to try it on a simulator. Don't try it in your ship. what will happen if you close it. Am I right, Mr. Janaka?
Perfectly right.
The better place to try out is the simulator, not the actual ship. Okay. There is a question, MEP and MIP difference. MIP is mean indicated pressure. Mean indicated pressure will be the average pressure in your cylinder, which produces so much of work. The pressure in the cylinder is not a constant pressure. You know, the pressure in a diesel engine cylinder is varying, and you know the PV diagram which you have draw like this. So if you take the average pressure, which gives the same work, we call that as MIP. But from MIP, if you use the plant formula, PLAN by 60 or 120, you will get what is called as indicated power. So indicated power is the actual work done by the working medium. The working medium is hot air inside the cylinder. It is actually producing this much of mechanical power. But the entire mechanical power in the cylinder cannot be available at the shaft, because some mechanical power is utilized internally. It is utilized by for driving attached pumps. The very important attached pump is the fuel injection pump. All engines have got their own fuel injection pumps, and energy is required for injecting the fuel. So the power required to drive the fuel injection pump is there. Power required to operate the exhaust valve is there. And there is always friction between all the moving parts within the engine. That is your piston, liner, bearings everywhere. And the energy for all of it has to come from the work done by the medium in the cylinder. So in the cylinder, I am doing so much of work. All of that work cannot come to the shaft. So the power which is available at the shaft is reduced by a small amount. And this ratio, we call it as mechanical efficiency. So if a diesel engine has got a mechanical efficiency of, let us say, 90%, that means 10% of its own power is used internally to take care of its own friction, to take care of its own attached pumps power. So if the power which is available at the outlet of the engine is effective power, that is what it can deliver. So to calculate the effective power, one of the simple ways to do is you take this indicated pressure and you multiply it by mechanical efficiency. So if the indicated pressure is coming as 20 bar and you multiply it by 0.9, which is a mechanical efficiency, 90%, then you will get 18 bar as your MEP. That is the difference. So mean effective pressure. So final power is going to be, if you, in the PLAN formula, you have to put MEP, not MIP. That is what you are going to get at the effective output of the engine. Okay, so indicated, it just means what is in the cylinder, because it is used with the indicated instrument. And then Sir Janaka sir, there is a question. Where is synchronous motor used apart from electrical propulsion?
The synchronous motors, wherever you want to have a good torque and constant speed application, we are using it. To my knowledge, in the ships where I have worked, synchronous motors were not used for any variable loads. Propulsion motors, we are taking it. Of course, when I use a synchronous motor, I must have a CPP. If I have a fixed pitch propeller, then variation of the speed will be difficult. The synchronous motor runs at a constant speed. So I have to change the voltage frequency ratio of the synchronous motor. Wherever you need a high torque and where the speed can remain constant, I can use the synchronous motor. Synchronous motor, remember, it will run at a constant speed. It's as per your output formula 2 pi nt by 60. When torque is increased, load is increased, speed has to reduce to take care of the torque. But synchronous motor will run at constant speed. So it gives a high torque, so such application can be applied. Is it sufficient, sir? The answer or anything else to be added?
That should be enough, sir.
Yeah, almost. I think we are completed 30 minutes. Skill time was 20 minutes, but still, I think I was just counting. We have at least 25 questions more and still flowing in. So
Many
I
are
don't think
there. We'll not be able. We'll take a few. We cannot answer all, but we'll answer them down the line.
Yeah, maybe we can just select some questions and
I'm selecting.
Yeah, you can name the person who is there, and then we can just.
So there is one question which is saying why VAT starts with 40% MCR, and how do we know VAT is activated like this? So all of you should be knowing this variable injection timing for fuel pumps. It is mainly introduced to save fuel, to improve fuel consumption. So the concept of saving fuel saving fuel is because compared to without VAT, if you run a fuel pump without VAT, it means it has got a constant beginning. Injection always begins at the same time, and end of injection varies with the load. But with VAT, what we are doing is we are advancing the time. So compared to, let us say, if it is 10 degrees before TDC fixed in a normal engine, with VAT, it can be 10 can become 10.5 or 11 advanced. You start earlier. And the idea is if you start the injection earlier, you can end the combustion also earlier. So peak pressure will go up, exhaust temperature will come down, and reduction of exhaust temperature always means there is better thermal efficiency, because in a diesel engine, any exhaust which is leaving the engine takes away heat. And if we can bring down the exhaust temperature, my engine will have better efficiency. And efficiency is better, your SFOC should come down, fuel consumption should come down. But the point is, if you keep on advancing the timing, then peak pressure keeps rising. But the compression pressure cannot rise. At low loads, compression pressure cannot be high, because compression pressure is based on how much scavenger is supplied. So at low load, scavenger is going to be less. And if we keep on advancing this fuel injection timing even at lower levels, then the difference between peak pressure and compression pressure becomes excessive. And that puts a lot of load on the piston rings and crown, because it's a sudden rise in pressure. So because of this, one reason is you should not bring in VAT at low loads. At something like 40% load or 50% load onwards, you can start using. Because otherwise the difference between compression and peak pressure is excessive. Your piston ring can break, crown develops cracks, bearings also can develop cracks. There is a second reason, when most of the time the vessel will not operate at such low power. It was not the case earlier. Nowadays it has happened that vessels operate at quite low power. But before it was not a case that you don't operate at 40% load and 30% load and all. Now vessels are operating at such low loads. But at such low loads you cannot use VAT, because it will cause a lot of damage to the parts. You somehow will be aware there are turbochargers coming with variable geometry nowadays, where turbocharger also is adjusted according to the load. In that case, you can get little better compression pressure at lower load. You can have better, you have variable valve timing also now. So you can adjust the valve timing and get better compression pressure. So compared to, let us say 10 years back, this 40% can be taken a little bit lower, because you can ensure better compression pressure. So this 40 is not a fixed value. It depends on what kind of turbocharging system you will have, whether you have variable exhaust valve timing also. Then it is possible to take it a little bit down. But you cannot take it too far down, otherwise the rings will fail. Okay. So that's the answer to this question. Janaka sir, there is one more question on boiler.
Tell me.
It is about swell and surge.
What you mean? Say swell and
I
shrink,
think the
or Sachin is wrong. I think it's swell and shrink depending on the load
Yeah, it
changes.
should be swell and shrink. Yeah, it should be swell and shrink. You can.
So when the load is increasing or the demand is increasing, the boiler pressure momentarily drops. That time there is a boiling on the surface of the boiler water. It shows as though there is a level is coming up, like the feed pump is on. There's a swell like. When the load demand is more, when more steam consumption is there, pressure is dropping because the consumption is more. So there's a bubbling taking place in the surface of the boiler water. It shows as though the level is going up and down. It's called as swelling. Shrinking is when that load is reduced. The pressure is increasing and the bubbling starts reducing. It shows as though the water cycle goes down and comes up again. So this is called a swell and shrink phenomenon, depending upon the load changes. When load is more, demand is more, it's a swell. When load is less, pressure is increasing, there is a shrinkage. Just to make it short for your question answer, it is swell and shrink, not swell and surge. The doubt clear, please. Or you want me to little more elaborate if you want me to go?
No, they will not be here, sir. So that should be sufficient.
Yeah, we don't have much time. I think there's one question, which is, what is the importance of vertical shaft adjustment in purifier? Mr. Venkatesan, I think if you can take that question.
Yeah. That one.
What is the importance of the vertical shaft adjustment in purifier?
Importance of vertical shaft adjustment in purifier. Okay. Now, a purifier is a machine with the static part. What we are seeing outside is only the static part, and inside there is a rotating part there. A lot of rotating parts are there, and how close these rotating parts are to the static parts, that has to be controlled by part here. Now the entire rotating part of this, that is the bowl of your purifier, is mounted on a tapered shaft. Tapered shaft is a vertical shaft, and then your tapered shaft is there, and the entire bowl is sitting on. And then when you are going to fix it to the rest of the entire system, and from the bottom there is the water that you are giving, the water that is given for desludging, and the water that is given for operation. That's called sealing, not sealing water, operating water, which lifts the bowl. All of them have to come through static parts. So there is a rotating part which is there, and then there are static parts. So the correct position of them is important. Otherwise, it will not operate, because there is this whole bowl is there, which is mounted on a tapered piece of a shaft. There are static parts here at the bottom, and there is a static part all around. So it is for making sure the entire system is in the correct position. That is the main purpose of this, including all the parts which are inside. Inside the purifier, you have the disc stack, and you have all the gravity disc and the centripetal pump. All those parts are there. So the relative position must be maintained correctly. That is the answer.
Okay. So should we take last, say 3 questions? Should we take it across? Because the questions will keep coming, but then can choose 3.
We will take. I will just check.
Yeah, this Venkatesan sir, regarding this compliance, SOLAS chapter 30.
Yes, sir. Yeah, you can take.
Can I go ahead, sir? Yeah.
Yes, sir. Please go ahead.
It is for the contracting governments also are subjected to IMO audits. That's the thing. It has come from 1st of January 2016. So by this, IMO is going to audit all the contracting governments. It could be Indian flag or it could be Liberian flag. That is the precise concept of that. Thank you.
Sir, just now one more question has come. That is also for you. It is give some information regarding flag dispensation and condition of class.
Oh, lovely, lovely. Yes, yes. Flag dispensation, I'll just give you one small example. Like we are supposed to have, let us say, a speed log. Speed log has gone into a kind of a repair, but then speed log is mandatory. So likewise, certain things, suppose what you call a life raft maybe has gone overboard during a cyclonic weather. In such extraordinary situations where the ship owner, despite of his due diligence, he is not able to tie up, so he'll go to the class, he'll go to the flag administration and request for a dispensation till the next port. So the flag will definitely look at the pros and cons as a case-to-case basis. They'll give you the dispensation. That is as far as the flag administration and dispensation is concerned. Coming to COC, it's condition of class. Condition of class. For example, I'll just tell you, like there is an overboard pipeline that has gone off. So we put a cement box or whatsoever it is, and we call the surveyor. He comes and sees it, and then he says, okay, I'm giving you extension, maximum 3 months, but that doesn't mean we will get all the 3 months. We may get about a month, or depending upon the intensity, and we are supposed to repair that. But that's not the entitlement. In case the repair cannot be, it cannot withstand for 3 months, he may ask us to do in the next port. That is known as condition of class. Condition of class is awarded by the classification society. So basically in sale and purchase of ships, we accept memoranda, we accept other things, but condition of class we normally don't accept when we are planning to purchase a second-hand vessel. That is the difference between dispensation and class. Also regarding manning, also somebody suddenly falls ill just prior departure. The logistics may not allow you to get somebody from the place and put him on board. Such cases also, we approach the flag administration for dispensation, and they'll give us a single voyage dispensation. And such things is always within the power of the flag administration. Hope I have answered your question.
There is one more question, which is, what are the technical implications if engines are put to crash stop in a real emergency? Can the engine be revived in this case? Now, crash stop means you are going from full sea speed and you are bringing it to a stop. Actually, the requirement for a ship is that not only just stop, the engine should be able to go astern. Not only just stop, it should be able to go astern, because as you know, a ship doesn't have a brake. The only way you can slow down a vessel is you need to go astern. So it is not rare. It happens that at quite a few times you may have to bring the engine definitely from full speed to stop. Does happen. And nothing should go wrong. The engine is designed for taking that. What is going to happen is there is going to be a sudden reduction in momentum. You're just cutting off the fuel. And then as far as the engine is concerned, it slows down quickly. We are not bothered too much about sudden reduction in load. The turbocharger will definitely surge. Turbocharger will surge, you will get a booming sound. And if you go and look at your filters will look like they are, backflushed. Like filter will become very clean. Sometimes the air filter gets blown out. So beyond that, nothing much usually happens. So it is not something. What I mean to say is when the movement is to protect the vessel from hitting another vessel, then there is no second thought. You have to stop. You even go astern. Having said that, there have been cases where some damage has happened, not by stop alone, but sometimes when the vessel has gone full astern. When you go full astern, the danger is that you are going to apply braking air for slowing down the engine. And then there have been cases where starting airline it has happened in my own ship. Luckily, our starting airline did not blow up, but our gasket came out. Starting airline gasket came out and we were still able to maneuver. But there are other vessels where their manifold itself took off. That a piece of the starting air manifold came out when they did a crash astern. not crash stop, but you do a crash turn, this happens. So crash turn only in an emergency. It is not to be done for, maneuvering as such. Crash stop, not so serious. It may happen at times. If it happens, you will call the bridge and find out what happened. Why did you do it? That's it.
Let me add
Yes, sir, please.
a little bit, sir, with your permission, Mr. Chan. And the engine is supposed to take crash test. And between the engine and the hull, I think the safety of the ship is most important. So
Yes.
definitely all these things have been taken into consideration. And crash test, if it is asked for, we can give without any hesitation. And absolutely, it is well within the normal rules. Thank you.
Exactly.
Thank you, sir.
So I think this is the last question we'll take because we're running out of time. There is one question which says, if the engine room crane trips while hanging on load, how to lower it? Now, if it trips, it trips means the motor is stopped. So your first attempt will be to see what has gone wrong and rectify it. But assuming that there is a serious damage to the motor, that you are not able to run the motor at all. If it's just a question of, if the question is saying trips, what will you do? So if it trips, what will you do? You'll reset and try to lower it again. But if you're not able to do anything at all because the motor is completely gone or damaged, then you cannot leave the weight hanging. So are there any emergency procedures for lowering it? Because you all should be knowing the hanging weight is held by brake inside. And the brake, depending on the type of crane, there will be two sets of brakes are there. One electromagnetic brake is there, another brake which is called a load brake. Now, whatever type of crane it is, this ability to lower under emergency condition is designed in it. It is not something we have to fabricate. It is all cranes have to have this feature that with the hanging piston, my motor runs out.
Yes.
Motor is burnt. You will not be having to do some innovation to find a new way of doing it. All cranes are built with this safety feature. So there is an emergency measure always in the crane, which usually involves releasing the brake gradually. The brake is holding it, not allowing it to come down. That is its job. So you need to release this brake gradually. So it will usually have an arrangement where you need to insert a bolt and you need to slightly tighten the bolt. So the actual mechanism varies, but you will be releasing the brake gradually.
No.
And this releasing of the brake gradually is an inbuilt design. It's a part of how all these systems are supposed to work. So look at your manual, it will show you where to fit the bolt and then do it gradually. Do it slightly so that it doesn't come down. Whatever additional precaution you can take, if you can do with some additional supports, you can do that. But for large weight like a piston, you will not have a chain block to take. It's a crane which is going to lift. You cannot find a chain block to support the piston. So you need to do it gradually, little bit loose, little bit tighten, like that you can bring it. What I'm trying to tell is, you don't have to do innovation. It is already there. The emergency procedure is already there in the crane. Part of all lifting devices, it will be there. So we have to follow that. Yeah. So I think with that we will. Sir, can we stop? We are reaching 6 o'clock.
Yeah, I think, because otherwise it will not end. I think we planned this as a feature of 20 minutes, which of course we were prepared to have it doubled to 40 minutes. But then, okay, now it's almost an hour. And sure, I think, thank you all, ladies and gentlemen, for being here and at very short notice. In fact, the whole concept of having this was just created basically 2 days back. On Thursday, we launched our mock orals. There was a time when, again, at 15 minutes notice, we went to our class 1 and second mates candidates, and we told whether you'll be ready to take up the orals, because generally it's a feature of our competency courses. But then we thought if you would be willing to go live and also be watched on YouTube, because that's a bigger challenge for both faculty and the students, because both have to be perfect, because the whole world is watching. Neither of them. Okay, student has a right to always go wrong, because then only is called a student. Okay, as regards faculty, yes, it was a great challenge, and I could say in the nautical side we have Captain Anand Radhakrishnan and Captain Subramanian Anand, who agreed to this 15 minutes notice, and they took it up. And of course, Mr. Venkatesh also did a class 1. It's already live on YouTube. And thereafter, on the same day, we thought, let's have it something different. Let the faculty be questioned. There have been examiners at MMDs, etc. But then let's see how they perform if they are going to be on orals, because each of them would have done about a decade or two back the orals. But then how far are they prepared? That was something which we want to test, and that's how we started this initiative. Thursday we did the nautical side, and today, being Saturday, we tried out the engineering panel. And since we have a large panel of faculty, we thought we'll be rotating. We'll have various faculty who would be acting as examiners on a periodical basis. To start with, let's see how the feedbacks come. And as regards the feedback, you find it's useful, because in midst of COVID-19, when everybody is with some seminar, some webmate, one phone, one webmate is there, second laptop is with some other webmate, you're all into many things, and still would I like to be a part of it. And I could glad to see that we reached over 100 of them, 100 participants were there today at this maiden voyage. I would say thank you all for being here, and we would certainly have this on regular feature. In addition to this, I would also like to once again welcome you all for the mock orals. You can have one-to-one orals with any of the faculty of your choice. He would be an examiner. You can choose from a list of about 30 faculty who are examiners. I think you could choose whether it's Venkateshan or one-to-one with Mr. Janaka, Mr. Ganpati Rao, anybody, or nautical side, Captain Anand or Captain Subramanian. And we would go function-wise. Function-wise, that's how we have modeled this. Function-wise, we would have this orals being taken as it is in MMD. So each function you can get yourself assessed, and at the end of this 20 minutes of each function, probably the faculty, that is examiner, would give you the gaps where you need to improve on. And that's a process which has come out of the box thinking, and the feedbacks received from the industry. Let's see how it goes. We require support, as we always say, that whatever the HIMT is today in 22 years, it's just based on feedback. We give a lot of importance to feedbacks, and what we have grown is just because of your feedbacks. Please give your ideas, please give your suggestions at efeedback@himtmarine.com. And sure, I think our team, our dedicated team of faculty would certainly like to contribute themselves and see that how we could reach globally, and in the interest of the profession, the seafaring profession, which has brought us all here. So thank you once again, ladies and gentlemen. It has been good to have you. Please take care in this tough times of COVID. Please take care of yourself and your family. Please stay at home, but do prepare yourself. Indian seafarers are doing a great job and international waters globally. And we could see, in fact, we should thank the Director of Shipping, who also has taken a lot of initiative to do that. So gear up yourself and let's make a wave in the international market. Thank you once again, Mr. Venkateshan, Mr. Janaka, Mr. Ganpati Rao. Thank you once again for being over here. And we would certainly like to have you again on a periodical basis. Next week, we'll have a few other faculty who would be coming across here, and we'll continue. Please subscribe to our HIMT YouTube channel so that you get live information as to when any changes are there, because every day there's some concept which is coming across. But I think I'm sure from today, 100 participants, at least I'll take up 3 feedbacks I'll get from a few of you who will make us work and implement it. So finally, it's not our idea, it's all your idea. Thank you. Thank you once again. Your final experience, starting with Mr. Janaka, how did you find this last parting note from your end as examiner? how did you part? Okay, you are on a student as an examiner. What I call you, I don't know. But then, still, what was your experience? Just a brief.
No,
1
this
minute
is
experience.
this will be really useful, and that persons who have got unnecessary confusions can be cleared to a correct level, so they learn better. So here in this platform, without any shy or anything, because nobody's face is seen here, they are able to ask openly questions. So they are able to understand and then get well. That's very important. This will be really a good, not only moral boosting, but it is a good improvement in the learning platform also for the students.
Thank you, Mr. Janaka. Thank you, Mr. Janaka. Thanks for these kind words. And let's go to Mr. Ganpati Rao. What has been your experience, sir?
Yes, sir. It's fantastic, nice. Today I played both the roles, double role, as the student and the learner also. I have learned a lot of things today, and we must thank the students for posing such questions, where it has really allowed us to brush our knowledge and refresh, and it is honing our skills also. And it's I would like to thank them for this extraordinary gesture. Thank you.
Thank you, sir. Thank you, Mr. Ganpati Rao. Yeah, over to you, Mr. Venkateshan. How did you find? I think you are the brainchild of all such concepts, and we can always say if anything crisis is there, crisis management, you are there. So I just initiated this idea, and certainly you were ready in a very short notice. So what has been your experience, sir?
Yeah, it is something which is useful, and it was always necessary. I think in one way, the same thing could have been done even before COVID came. But COVID has made us realize opportunities which we are not exploiting, and it is definitely something that we will take forward. And it's a learning, like Ganpati Rao sir said, it is a learning experience for us also. It is, as a teacher, your learning never stops. If the day you stop learning, you are not fit to be a teacher anymore. That has been our belief all the time. And definitely, going online gives us the chance to face questions from a wide range of students, from wherever they are. There's no limitation. And like Mr. Janaka sir said, being in chat, they have a little more freedom. They don't have to ask verbally or to feel shy about us. We are getting good questions. We didn't get enough time to address all of them because it's a large number. But we'll post the answers in the channel. We keep doing it as there is a procedure. We can take it up. And we can set in procedures that questions can be posted in advance also, whatever it is. So as we go down the line, we'll think of improving this further.
Yeah, our CPU is there. I think we have all the students who are going to give us ideas. We don't have to think. We need to just operate. So, and I'm sure our faculty are willing to operate. And so, sure, I think, thank you all students. And I think from the industry, those who are there watching us, we would like to have such sessions more. And I think as we always been setting some benchmark, we would like to see that others also please follow across. And because it's certainly good for the industry. We have always believed that there is nothing like competition. Competition, when people ask this question, who are competitors? I think competitors are the real supporters of us. Today, if faculty have been able to come live, I think they would have been certainly confident that their knowledge is, I think they are prepared well. And even I'll say no person is perfect. And even if we do not have any answers readily, we'll certainly come back to you. So with that note, once again, thanking each of you for being here, and see you. Have a good weekend and be safe. Again, tomorrow being Sunday, I think at least at Tamil Nadu, Chennai, I think it's complete lockdown. But we have internationally everybody, many of the other countries also, there is a lockdown. But then please spend your time preparing and also giving some homework to our faculty for the next time. Prepare yourself and try to see where you have doubts. Get ready with your doubts. And next week, again, we'll be back. Thank you very much. Thanks a lot. Thanks once again to each of you.
Thank you.
Thank you, sir.
Thank you. Moderator, can we cut off offline?
Of the Zoom.
Moderator, we are offline now.
Available, sir.
Disable. Jagdish of music. Okay. Niranjan,